Okay, so you guys can look up here and see we've got some new formulas tonight. So you might want to write them down. Everybody get your pencils going. Everybody have your pencils out. Okay, these, and I'll write them over on the sideboard, are your alpha plus beta formulas for tangent. We don't like the ones for tangent as well because it usually means that we're going to have radicals in the denominator and we're going to have to rationalize those. Michael, are we paying attention and not talking? Okay, so we've got tangent of alpha plus beta ends up being tangent alpha plus tangent beta. That's nice. But it's divided by now 1 minus tangent of alpha times tangent of beta. So there's always 1 plus and 1 minus. If it starts plus, it's plus on top, which means it's minus on the bottom. Tangent of alpha minus beta starts with the minus on top, so you get tangent of alpha minus tangent of beta, and puts the plus on the bottom. 1 plus tangent of alpha times the tangent of beta. Does everybody have the formulas written down? Right, the proof is here. Again, you're welcome to look at it. I think most of you don't really care, but all we did was take the sine of alpha plus beta over the cosine of alpha plus beta, because that's what tangent is, sine over cosine. Expand those formulas out, get common denominators, combine them, and get them to come out as tangent of alpha plus tangent of beta over 1 minus tangent alpha tangent of beta. So you can follow it through when you get home if you want. The proof is there. So tonight, very similar to last night, they're going to ask you, is this first guy right here, you guys, in expanded form or condensed form? Expanded. So I want you to take and write it on your paper right now. I want to make sure everybody's got this example down, and I want you to condense it. You do it right now. So write number 1 on your paper. Okay, which formula is that? Is that the tangent of alpha plus beta or the tangent of alpha minus beta?
Alpha plus beta.
Alpha plus beta. And what's alpha in that case? 170. What's beta? 10. So it shouldn't take long to realize all they want you to do with that one is do the tangent of 170 plus 10, which is the tangent of 180. Then you have to go remember your unit circle values. 180 is the same thing as pi, and the tangent at pi, or the y over x there, is 0. Okay, how are we feeling about that? You've got to remember your tangent values. Okay, now this is a simplifying one. They're going to ask you tonight to simplify the tangent of pi over 3 plus theta when the tangent of theta is 2/3. So first expand it out using your alpha plus beta formula. So that's what I did right below it. It should be the same thing as the tangent of pi over 3, tangent of theta, divided by 1 minus tangent pi over 3 tangent theta. Okay, you guys go fill in right now what you think you should be filling in for those things. You're trying to simplify it now. You should have enough information to get some numbers in there and try to get it simplified. Okay, Eric, what's the tangent of pi over 3? And you should be doing this and not your homework, so let's make sure we're working on this. Okay, tangent at pi over 3 up there, you should complete with radical 3. Mike, what are you going to put for tangent of theta? Don't. What? 2/3, because what does it say in the problem? Tangent of theta equals 2/3, okay? So if we replace that in each one of those spots, you can see you're going to get radical 3 plus the 2/3, and then radical 3, or 1 minus radical 3 times 2/3. Okay, for me, I don't want to work with the complex fractions, so I'm going to get rid of the denominator there first. I don't want denominators of 3. Common denominator there for those guys is 3. So I'm going to multiply the top and the bottom by 3. When I distribute through, I'm going to get 3 radical 3. Distribute through here, the 3's will cancel, and you're going to get 2. On the bottom, distribute through, and you're going to get 3. Distribute through, and you're going to get 2 radical 3. You can't leave it like this. You've got a radical in the denominator, so you multiply by the conjugate of 3 plus 2 radical 3 and 3 plus 2 radical 3, which is the factor of 1. Now you got to FOIL the whole thing out. Check your foiling on your paper. But the final answer they're going to give you in the homework tonight will be 24 plus 13 radical 3 all over negative 3. They may take that negative through the top and do like negative 24 minus 13 radical 3 and not leave it on the bottom. I don't care. Either leave it on the bottom or take it through the top. So you can see this is the hardest part of the difference between sine, cosine, and then the tangent one. If you're left with a radical, it's going to be down there in that denominator, and you're going to have to multiply by the conjugate to clear it. A lot of your calculators are doing this for you, and so you're not showing it on the test, and you're losing points because I can't check you know the process. So you're welcome to use your calculators, but use it for a checking device and make sure you show me the multiplying by the conjugate so I know where you get your answer. Okay? Questions so far? Okay. All right. Now this one comes up with the tangent inverse step, and there's some tangent inverse stuff tonight. Do we remember what tangent inverse means? Okay, we're going to go through it. They ask you to show that the tangent of alpha plus beta equals negative 7. When the tangent of alpha equals tangent inverse 3 and beta equals tangent inverse 1/2. Okay, I'm going to go ahead and just come to the board and do this one. All right, I'm going to pull these down, but I am going to come to the board and actually work this one out. I'm going to open it up so that if you're at home and you want to look at it, you can. But I'm going to cut it off at this point and go to the board and do these two, okay? Because I feel like I need to work them out on the board, but I wanted to make sure they're there for somebody if they need to look online to get them. Okay, so if you're online and you're looking, you can just pause it at this point. So.